All right, hello everyone. Welcome to this video. This is a conceptual problem involving the ideal gas law, but it's unique because we're going to have two unknown variables in this problem. And the problem has to do with what can we say about the solution given that we have two unknown variables. So without actually solving for them both, what can we say about the unknown variables? So let's go to the ideal gas law and say PV is equal to NKT. And the easiest place to start is just to imagine that you have a gas that's being held, that's in equilibrium, and imagine that the number of moles is being held constant, and somebody comes along and raises the temperature of the system. So when the temperature of the system gets higher, this right-hand side of the equation will get larger, and we could ask ourselves, what happens to the left-hand side of the equation? What can we say about these two unknown pressure and volume? And the answer is we can't really know exactly what pressure or volume is going to do. Like just because this temperature gets increased, we can't say for sure that, oh, volume is going to stay constant and pressure is also going to increase. We can't necessarily say this because we don't know that the volume is going to be held constant necessarily in the scenario of this problem. And similarly, if we increase temperature, we don't know for sure that pressure will stay constant and volume will increase because that's not given in the problem either. So if you don't know what the pressure and the volume are doing and you have an increase in temperature, all you can say is that the product of temperature and volume must increase. With the right numbers, that could mean that just pressure increased, it could mean that just volume increased, it could mean that they both increased, it could even mean that one increases by a lot and one decreases by a little, but the product still actually increases. But it's the product will increase in response to the change in temperature. So this is just kind of like almost like a logic puzzle in that you have the ideal gas law, and if you change one side of the equation, what is the minimum you can say about the other side, and that's that the product of those variables here is going to increase. Of course, that was just one example. We could go back to PV equals NKT. Imagine you had a case where the volume was going to change by a specific amount and N was fixed. So we could do P over T is equal to NK over V. And now you could say, what happens if I increase volume? What can I say about pressure and temperature? So imagine like a balloon, you allow the balloon to, you decrease the size of the balloon, let's say. So if you decrease the size of the balloon, if this volume is getting smaller, what can we say about how pressure and temperature are going to change? You can't just assume that one will be fixed and not the other. So like if you come over here, like I'm going to analyze volume. If volume decreases, we can't just say that temperature is fixed and that pressure is going to decrease. Can't say that. If volume decreases, we can't automatically assume that pressure will stay constant and temperature will, that temperature will actually increase in that case. We can't say that because we don't know that pressure is constant. All you can say is that if this right-hand side is getting smaller, then the left-hand side is going to have to get bigger. Let me just clarify, in this particular case, if this volume is getting smaller, that's the denominator getting smaller. This whole fraction is actually going to get bigger. And so over here, we need this whole side. We need the P over the T. That ratio is going to have to get bigger in order to match the fact that volume was decreasing over here, which meant that overall that fraction was getting bigger. So if the right-hand side gets bigger, the left-hand side gets bigger, but you can't assume that one of these variables is constant if you haven't been told that in the problem. All you know is that that ratio is going to have to get bigger. And it could happen by a pure change in pressure, a pure change in temperature, or it could happen by changing pressure and temperature. So that's the concept here, guys. We're using the ideal gas law, but we're just thinking about what is the minimum statement we can make about the changes when you have two unknown variables. And we have to use the structure of the ideal gas law to figure that out. Thanks so much for watching, guys, and I'll see you in the next video.